This video is to help you solve word problems like the ones in section 4C, especially this first part is for 4C.1. Since we've just practiced Pythagoras' theorem, you can assume that you will be able to use Pythagoras' theorem to solve each of these word problems. It's hard to teach you exactly how to solve each word problem because the word problems are always slightly different. And it would take a lot of time for me to show you one example of each word problem that you could use as a recipe for solving all the rest. That's not really the point either, because in mathematics we have to solve problems all the time. That's what math is for, and the skills needed to solve problems like these ones are important to learn more generally than just solving these particular problems. So I'm going to try to lead you through 6 steps that are applicable to all kinds of problem solving, not just these ones, but we'll use these particular examples to practice. So the first step here to solving word problems is to make sure you understand the problem. That might seem obvious, but I don't know how many times I've helped students who say, "I'm completely stuck, I have no idea what to do." And all their problem is that they didn't know what the word sum meant, or maybe they didn't know what product meant. And that, of course, makes it difficult to answer the question if you're asked to find the sum of 2 numbers. So what's really, really important at the beginning is that you force yourself to look at what is the problem and do I understand what it means? Are there any new words? Maybe you have to define what sum is, or maybe you need to know what diagonal is. At the end of these examples, I'll give some typical vocabulary for the problems in 4C.1. But just in general, you should make sure you understand other English words like consecutive or other things that may come up. The next step, particularly when dealing with something like Pythagoras' theorem, which is geometry, is to draw a diagram. I don't want to see anyone asking me for help with a problem if you haven't tried to draw it first. So if you've understood the problem, you should be able to draw a diagram that goes with it. Probably if you can't draw a diagram, you haven't understood what you're being asked for, because somewhere in there's going to be a right angle triangle, like this or something else, because otherwise we wouldn't be able to apply Pythagoras' theorem at all. So somewhere in there's going to be a right angle triangle, and you're looking for at least 2 sides being given so you can find the hypotenuse, 2 legs, or maybe the hypotenuse and 1 side so you can find one of the other sides. Okay, the second step is to write down what you know. Usually, if you've drawn a diagram, that means labeling the diagram. So once I know, for example, that this length is 4 centimeters, then I can write that in and say it's 4 centimeters. So write down everything you know about the diagram. The next step is then to take the thing that you don't know, the thing you want to find out, it's probably the question in the problem, and call it a variable. X, or you could also use N, or maybe you want to use D for diagonal. You can use whatever letter you want. Let's make that a clear D. Okay, the next step is then to write an equation. And in this exercise, you're always going to be using Pythagoras' theorem, so your equation will look something like this. Keep in mind you're not always solving for the hypotenuse, so you might also be looking for this part and have to rearrange it. That's what you do in the next step, is rearrange if needed and solve the equation. Find out what is your x, what is it equal to. And then the last step is to go back and say, well, what did I find? I introduced the x, that's what we did here in number 3. There was no x in the original question. So I have to figure out again, what was x standing for? Yeah, what did it mean? Was it diagonal? Was it a distance? Was it a height of something? Check to see if the answer needs units. If you were given things in centimeters, then you should also give your answer in centimeters. And then finally write an answer to the question. Usually as a full sentence, can be short sentences, but there should be something there that relates back to the problem, not just my little x equals something. Okay, let's take an example from your textbook and see if we can follow these 6 steps that we've just gone through. This is example 10 from section 4C.1. It says a rhombus has diagonals of length 6 centimeters and 8 centimeters. find the length of its sides. So first we have to check if we understand all the words. Do you know what a rhombus is? Do you know what diagonals are? And do you know what lengths and sides are? So review of rhombus. A rhombus is a square tipped on its side. So there are a few important properties of rhombuses that this problem assumes you know. And one is that all the sides are equal. But since we're dealing with Pythagoras' theorem, we're also looking for right-angled triangles, and here with a rhombus, I don't have any right-angled triangles. If I were dealing with a square or a rectangle, of course, the right-angled triangles are obvious because they're in the corners. So as soon as I take a diagonal across the shape, easier if you do that with a ruler, of course, but let's try that again. Then half of this rectangle is a right angle. But in a rhombus, that's not so obvious. What you may have learned in previous math courses is when I take the diagonals of a rhombus, like that, then these always form right angles. So there's your right angle triangle on a rhombus. Okay, let's look at where the information that we need is going to go before we try to draw our diagram. I've already defined diagonal as well now. It's a line going from one corner to the opposite corner. So if I look at where 6 and 8 centimeters are going to go, it's telling me those are the lengths of the diagonals. So the shorter one is 6 centimeters and the longer one is 8. So I start with that as a diagram, but I don't have a lot of room to write the numbers on here, so I'm going to write another diagram with one of the triangles blown up a bit. I'm still in the part understanding the problem. So this is now one of these triangles. Let's make it this one. So if I color that one in, that colored triangle is now being blown up to look like this. I have to then write in what I know, but I'm going to interpret it a little bit differently because the whole length here, this 6 centimeters, is the entire thing, and on my triangle I only have half of it. So I'm going to write in 3 here for half of 6, and that's this side here. And the longer diagonal is 8, so if I cut that one in half, then this length, which is the same as this one on my diagram, is 4. Here I have a triangle, and I also need to look at what I'm looking for. So I'm going to look for the length of the sides. Well, here is one of my sides, so let's call that x. Is that going to be the same as all the other sides? And yes, because it's a rhombus, all the sides are equal. So I can call that x. And I'm looking for the lengths. I'm just going to write that here because I'd like to open up the other side of the page and go back to our points. And now we can see we've done number 1, defined new words that were new to us. We drew a diagram, wrote down on the diagram what we knew. We used x to represent what we wanted to find out. So now I'm on step 4, writing the equation. On my right angle triangle, the thing I'm trying to find out is the hypotenuse. So I'll write 3 squared plus 4 squared equals x squared, or I could have called it L squared for length. Now I'm going to solve the equation. So if I'm looking for x, we'll simplify this side first. I have 9 plus 16, and 9 plus 16 is 25. So I have 25 equal to x squared. That means x is equal to the square root of 25, and I have to be careful when I'm square rooting things. I always have a positive and a negative possibility, because I could have 5 or negative 5 would give me an answer of 25 when I square them. Okay, but I'm talking about the length of a rhombus, and lengths are never negative, so I can actually discard the negative answer, and x equals 5 is the answer to this equation. Not quite done, because I have to remember what x stood for. X stood for the length of the rhombus. Does it need units? I should check my original problem. I think was given in centimeters. Yes, so these were in centimeters. So I'll have to put units on the answer, and then I'm going to write an answer to the question. So the length of the rhombus is 5 centimeters. And that's my final answer. Okay, let's try one more example before you try it on your own. This example comes from the exercise C.1, number 7. A yacht sails 5 kilometers due west and then 8 kilometers due south. How far is it from its starting point? Okay, yacht might be a new word for some. It's also pronounced a little bit differently than it's spelt. In German you would say Yacht, but in English we say a yacht. And it's a type of boat or type of ship. It's sailing, so it's on the water. And we're going to try to draw a diagram of this situation. It first goes from a starting point due west. West is to the left, so I'm going to start back here and go 5 kilometers west and then 8 kilometers due south. Due just means straight, so we don't have to worry about it going off on an angle. Okay, I'm going to write in what I know. 5 kilometers west and 8 kilometers south. And then I want to know how far it is from its starting point. So if I want to know what the distance is from here all the way to there, then that is going to give me my answer, and that very nicely also forms a right angle triangle. I have my diagram, I've written in what I know, and this is what I'm looking for, so I'll call that X. It's the hypotenuse again, so we're lucky that we can simply write 5 squared plus 8 squared equals x squared, and go ahead and solve the problem. 25 plus 64 x squared, and then I get 89 equals x squared. This one doesn't work out evenly, so I'll need a calculator. I know the square root of 81 is 9, so I know it'll be about 9 point something. That also makes sense that it's a little longer than the other sides, but I'll need a calculator to figure that out. I'm going to stop there. Yeah, you still need your sentence. It's so many kilometers from the starting point. But just before we go and get started on the work, I would like to show you an example which is not the hypotenuse. So let's just take this problem and do the same thing, but instead of making 8 that part going due south, we'll call this 5 and this 8 and look for this one. So now the hypotenuse is given, and I'm actually looking for one of the legs. You would still write it as Pythagoras' theorem, x squared plus 5 squared equals 8 squared. Remember the shorter side, the legs of the triangle always get added together on one side. But when I simplify it, I'm going to need to isolate the x all by itself. So if I do 25 here and 64 here, then I'm going to get x squared equals 64 minus 25 to get the x squared by itself. 64 minus 5 would be 59, and then minus another 20 is 39. So x squared is equal to 39. That means x is going to be equal to the square root of 39. Again, we don't have to worry about the negative answer because it's a length. Square root of 39 does not have a perfect square as a factor. It has 3 and 13 as factors, but no perfect squares. So I either leave it like that if I'm going to leave it as a radical, or I use a calculator to determine what the square root of 39 is. It'll be 6 point something. Yeah? And then answer again in a sentence. Okay, so watch out for that. If the thing you're looking for is not the hypotenuse, then make sure that you still set up the equation right and rearrange it to solve for the thing you're looking for. Okay, for those of you who might want a little help with vocabulary, let me mention another couple of words that you might need to know. Most of them we've defined already, but there's a couple of others that show up. Remember, area is the space, the two-dimensional space that an object takes up. So if I'm looking for the area, then I want this. And area is always given in squared units, so you might have centimeters squared or meters squared, because if I want the inside space, then I can't just take a length, I have to have a little box here. I have to know how many boxes fit in the shape. Okay, perimeter is the length around a shape. So if I'm looking for the perimeter of a triangle, then I'm going to add up this plus this plus this. Yeah, so I'll find all the lengths of the sides and then add them together. And one last reminder, the word dimensions come up when it asks you for what are the dimensions of the rectangle, or maybe the dimensions of the rectangle are, and the dimensions define how big it is. So for something like a rectangle or a square, the dimensions are the width, which we usually label the smaller side even if it's not wide, and the length is usually the longer side. So that's simply what it's asking you for. If it asks for the dimensions, then you have to provide the width and the length, these two numbers, as their dimensions. And dimensions are usually given with a little cross between them. So you might talk about a 3x8 photograph, right? 3 centimeters by 8 centimeters as the size of your photograph. That's where dimensions are used. Okay, that should be enough, and you are ready to do section 4C.1.